Okay, great. All right. So can I just see one more night? Can you guys hear me okay and everything? Awesome. All right, so where did that document go? All right, so what I've done is I have copied and pasted this little excerpt from section 11.2 from your textbook. And what this is a formula for calculating the value of something, present value of something, or the past value of something given CPI measures for the respective time periods. And I'll tell you up front, I don't find this very useful. So I'll show you how to do it the way it is in the text. And then I'll show you what I think is a far more useful way to do this. So here is the formula as it's listed in the text. And then here I've just put it in again with abbreviated symbols. And over here is what these symbols represent. So what we want to know is the total value of, I think it was Babe Ruth's salary today, what it would be, given that he was making $80,000 back in, I think it was 1931 was the time period one, back when the CPI was at 15.2. And then in today's values, the CPI is at 251. So I basically just plug these values into the formula and I'll get the answer. So I'll work, let's say, right here in this cell. So I can hit equals. And there we go. So I have the principal, that's that, times the CPI2 divided by CPI1. And that should give me today's dollars. Did I make a mistake here? I did. I divided CPI1 by CPI2. There we go. That explains that. So CPI2 divided by CPI1. That gives me what it would be worth today. And let's see, 3 zeros. That's $1,321,052 with some change is what he would be making in today's dollars, given what he was making back in the early 1930s and what CPI was in the early 1930s compared to what it is today. So that's not hard to do. It's just plugging something into a formula. But the thing I don't like about it is it's not very useful to you, because I have on the business news channel right now. I watch it all the time. And, you know, even though inflation is big talk right now, you do not ever hear someone cite what the CPI index currently measures. It's never, if you watch the business news, read the Wall Street Journal or the Financial Times every day of your life, all day, every day, the number of times you will hear what the CPI index measure is exactly zero. You have to go to bls.gov and look it up to get that information. It's not something that people use for anything. What is cited often is what the inflation rate is or has been over a given period of time. Those flow variables or those rates of change are what are cited all the time. So that being able to apply those calculate and apply those is just beyond 1,000 times more useful than muddling through this formula while you have to, because it's in your textbook for one semester, you'll muddle through the thing and then you completely will forget it. It won't do you any good. And it's not just our textbook that has this in there. They all do this. And it's part of the homework question. So you may have already done it or you will be doing it soon. But you can do it that way, or you can do it this way I'm going to show you, which will be more useful. See, whenever you have two values, a before and an after, and you're given that information, you can get the rate of change in the before and after, or the old and the new. That in the case of CPI, that rate of change between one CPI measure and another CPI measure, well, that's inflation, that rate of growth. So I can find out what the inflation rate has been since 1931 to present by simply using a formula I like to, I think has a nice little jingle to it. I'll fill it in here so you can see it and have it. The total value of something is equal to new minus old divided by old. And then just to move the decimal over, you multiply by 100. I'm sorry, that's not the total value of it. That's the inflation. That's the rate of change. Now it's messed up because it's trying to. Sorry, hold on. The rate is equal to new minus old over old. Doesn't hurt to repeat that multiple times so it sticks in your memory anyway, times 100. This is something I actually use all the time. Anytime, like in the prompt that I gave you to think about, anytime you're looking for percent change, it's everywhere and always new minus old over old. And then the 100 piece is really just to move the decimal over. Let me see if I can expand that so you can see it better. So just remember that little jingle, new minus old over old. So that's true whether you're talking about the price of an individual good or whether you're talking about the inflation rate from an old CPI to a new CPI measure, or whether you're talking about how much bacteria has grown in a petri dish, given how many were alive at one time period and how many are alive in another time period. In other words, it's useful for a number of your classes, not just economics, but it's very useful for economics and finance and accounting. So we can find out what that was for CPI. So if we want to know what the inflation rate was from the present time, how much inflation has happened since from the present time back to that earlier time, well, oops, not. I'm going to fill this in. I'm going to use double brackets for the top here. My new CPI is 251. My old was 15.2. And now I divide by that old rate again, or old figure again, 15.2. And then just to move the decimal over, I will multiply by 100. That just moves the decimal over. I have a bad habit of not thinking of that because to me, when I see a decimal, like if I see 0.10, to me that's 10%. So I convert it in my mind, but technically I'm multiplying by 100 to move the decimal over. So we can see that from 1931 to present, prices have risen 1,551%. That's what we can see by using those CPI numbers, is to get the inflation rate over the time period that we're talking about, which is actually quite useful because now I could go back and forth from present values of things to past values or from past values to present values. So what I'm going to do is take away that multiplying by 100 and convert this back to a decimal. Let me get back in my formula here. Actually, you know what I'm going to do? I'm going to keep it. Oh, don't do that. I'm going to keep it there. I take back what I said. I'm going to keep it there. I'm going to try to keep it there. I seem to have messed it up. I don't know why it won't let me just keep that formula anymore. Okay, I'll just delete it. So let me just do it again. I'm not gonna move over the decimal. That's how you find the percent rate, is to move or change it to a percent, is to move over the decimal. So I'm just not going to do that. I'm going to do new minus old over old. So we're talking about 251 minus 15.2 divided by 15.2. And so what that's going to be is the decimal form of the rate of change of prices over that time period. and that prices have gone up as it's the same thing. That's 15.51. So that's 1,551% because I could move that decimal over. But it's useful in decimal form because in decimal form, anytime you want to answer questions like you did where something goes from $1 to $1.10, you have to say to yourself, what am I doing? If I know that something, you can look at it two ways. If something went from $1 to $1.10, that means the new one is $1.10 minus the old one's $1 divided by $1. And you're going to find that that's a 0.10 is your solution, which is a 10% increase in prices. Now, if, on the other hand, you were told that you were given a question like, suppose something was $1 and it rose 20%. Well, most of us would know right off the top of our heads that would make it $1.20. So the question is, what is the mathematical operation you're doing in your mind when you do that mental math? And I'll show you what that operation is that you're doing is this formula right here. The total value of something or the present value of something is equal to the principal amount, which the total value of something was that dollar. Actually, that's what we're trying to solve in that last question. The principal amount was the dollar. And this formula is always what you're doing in your mind when you do that kind of math. You're doing 1 plus the rate. And that's how you know that if something goes from $1 up by 20%, it becomes $1.20. Because think about what you just did there. You know the 20% is 20 cents, 0.20. But you still have that original dollar. That's the principal. So how do you make that work mathematically? To keep the original dollar, you must be multiplying it by the 1 to keep it, plus the 20 cents. That sums to $1.20. I hope that's making sense. Now let's apply that to our Babe Ruth salary question. So we know that Babe Ruth's principal amount was 80,000 back then. That's the correct number of zeros. If I multiply that by 1 plus the interest rate that we just calculated there as a decimal, why are you not working? Oh, because there's no open. No, there is an open parentheses. Oh, I know it doesn't like it when I write it the way we write. Okay, that should do it. And look at that. Look at that. Compare that number to that number right there. Is that cool or what? So this number right here, we calculated by using the textbook formula for finding the present value of something given two CPI data points, which I think is really useless because you'll never find CPI data points unless you go to get them. What's useful is being able to find percent change of anything, which is what we have here in decimal form, and apply it to older values to find the new value, which is what we did here. So down here at the bottom of the screen, again, you can see those formulas written out in their spreadsheet way. That's the principal times 1 plus the rate of growth. And the rate of growth I grabbed from here because rate of growth is always new minus old divided by old. That leaves it as a decimal. This thing right here, or this thing right here, however you want to look at it, principal times 1 plus r, this is hugely useful as well. Just like finding percent change is something that you might have to do in any one of your classes with any kind of math at all. This is also like that. This is the foundation for any kind of compounding growth. Principal times 1 plus r. If it's compounded quarterly or by some periods, then it's just 1 plus r divided by that raised to the number of times it's compounded times t as an exponent up here. But it's still the same foundation. Continuous compounding is, I remember, is PERT, That's principal times the numerical value E raised to the rate times the amount of time. But it's still the same foundation. So if you get in the habit of practicing with this and understand how to apply this, it will be far more useful to you in your other classes and in your life going forward than just using this formula just one time for your homework in your economics class and then forgetting it. So that's why I wanted to share with you both ways how to do this. So that's about all I have to say about that. Let me get this back up here and stop sharing the screen here. Okay, I think I've successfully stopped sharing the screen. I'd also like to stop recording if I can.